Okay, so let's think about your digital life like it's a fortress. Today, we're not just putting up some walls, we're designing a full-on, fail-safe architecture. This is literally the blueprint to survive a total, catastrophic Windows lockout and pull your digital life back from the absolute brink.
I mean, just think about that for a second. What if everything, your photos, your documents, your entire history, was just gone? It's a terrifying thought, right? One bad update, one forgotten password, and poof. This isn't just some hypothetical scare tactic. It's a very real threat. And today, we're building the plan to make sure it never happens to you.
And this image, man, it perfectly captures the anatomy of that lockout. See, it's not just one thing that goes wrong. It's a domino effect, a cascade of disasters, where first your hardware fails, then your local login gets rejected, your password fallback is useless, your cloud recovery is offline, and the final nail in the coffin, your encryption key is nowhere to be found.
That's right, 5 different gates have to fail, one after the other, for you to lose everything. But here's the crucial part. This chain reaction is entirely preventable. If we can just break the chain at any one of these gates, we win. And that is exactly what we're going to learn how to do right now.
So, how do we stop it? Well, we shift from focusing on the problem to embracing the solution, a layered defense philosophy. Think of this as the actual blueprint for your personal digital fortress, built on some really smart principles from fail-safe engineering. In the core principle, the absolute heart of this whole thing is redundancy. But listen, this isn't just about having backups. It's about having different kinds of backups. The goal is to make sure that a weakness in one layer of your defense is covered by a completely different kind of strength in the next layer. They should never, ever be able to fail in the same way.
Okay, so our fortress has 4 distinct layers. We're going to start at the very bottom at the hardware level with something called the TPM. That's a special security chip on your motherboard. Then we move up to local offline failsafes right there on your operating system. Above that, we've got our cloud vaults. And for the final, absolute, ultimate protection, we have external physical keys.
Now this visual, this is where it all clicks. It shows you the whole philosophy in action. A threat might manage to break through Layer 1, the hardware, but because Layer 2's security measures are totally different, they don't have the same weakness, the attack gets isolated and neutralized right there. The attack vector is broken, and that catastrophic cascade just stops dead in its tracks.
All right, enough theory. Let's get practical and see how you actually build this thing. We're going to start at the foundation of our entire security structure, the hardware root of trust, the TPM.
So the TPM is like the silicon heart of your security. But here's the deal. It's not invincible. A bad firmware update, that low-level BIOS or UEFI software running your motherboard, or physical tampering, or even just messing up its settings can corrupt it. And that, right there, is the first gate of failure in that whole lockout scenario we saw earlier.
But we can prevent this, and this is probably the most critical, actionable step you can take. You have to proactively suspend BitLocker before you do any firmware or BIOS updates. You can see the exact command right on the screen. It's a simple little step that prevents the update from accidentally triggering a total lockout. Just don't forget to re-enable it when you're done. So, what happens if your TPM fails anyway, or you can't get online to recover? This is where your local failsafes become absolutely critical. Having a backup, local-only administrator account, we'll call it a phantom admin, is your secret weapon. It operates completely offline. It doesn't need the TPM or the cloud, so it can just waltz right past those first few gates of failure. It's also how you can fix things like a corrupted PIN, another little offline trick that keeps you in control. Okay, now let's talk about the single most important piece of this entire architecture. If everything else fails, the hardware, the passwords, the cloud accounts, there is one thing that stands between you and total, irreversible data loss.
This number, 48, this is the length of the key to your entire digital kingdom.
It's the 48-digit BitLocker recovery key. This isn't just another password, it's the fundamental mathematical master key. It bypasses the TPM, it bypasses Windows Hello, it bypasses your password. It directly unlocks the encrypted data on your drive. It is your last line of defense, your ultimate barrier.
And this brings us to the most important rule of all. Please, whatever you do, burn this into your memory. Storing your only copy of this key on the drive it's supposed to protect, that's like locking the key to a safe inside the safe itself. The moment you do that, the key becomes functionally useless. It's gone.
So, if we can't store the key on the drive, where in the world do we put it?
Well, this is where we expand our defenses beyond a single device or a single company. We're going to use something called cross-platform redundancy.
This storage resiliency matrix just lays out all our options perfectly. Look, relying only on your Microsoft account, that's a huge vulnerability. What happens if you get locked out of that account? True resilience means having at least one cloud backup, say in a Google or an iCloud vault, and at least one completely offline physical backup. And just notice the security level for a printed hard copy. Ultimate. Yeah, I'm talking about good old-fashioned paper.
And this is exactly how you achieve that resilience in the real world. You use what we call ecosystem cross-pollination. It just means you mix it up. Store your Microsoft BitLocker key inside your Google Password Manager. Use your iPhone's secure notes to hold important credentials. This way, if one company has an outage or locks your account, it doesn't take down your entire system.
This redundancy web just ties it all together so beautifully. Your Apple device helps secure your Google Vault, which holds the keys to your Microsoft world. A little hardware token, like a YubiKey, can secure all of them at the same time. No single point of failure can destroy your access, because everything is interconnected and backs each other up. All right, we have covered a lot of ground. The theory, the threats, the architecture. So now let's bring it all together into a final, actionable master plan that you can go and use today.
Here it is, your master recovery checklist. Number 1, store that 48-digit BitLocker key in at least 3 places, one in the cloud, one on a separate device, and one physical copy. 2, secure your main ecosystem passwords. 3, create that local fallback phantom admin account. 4, create a physical escrow on an encrypted USB drive. And finally, number 5, have a system image backup ready for a worst-case wipe and restore scenario.
So you might be thinking, is all of this overkill? Absolutely not. And I want you to remember this guiding principle. Building these layers isn't being paranoid, it's being smart. It is the fundamental law that ensures your digital life remains yours no matter what goes wrong. So the real question is, how many layers have you built?